Okay, now what we're looking at is the, please disregard these notations over here. This is the trace coming from pin 3 of the 555 timer, and this is the trace coming from the drain of the MOSFET. Okay, and there you go. I'm just using one lead of this resistor to make the connection to the hole there, so don't worry about that. That's irrelevant. Am I going to have to cut that off to prove it? Anyway, and then there's the drain of the MOSFET. Okay, so you see this parasitic oscillation right there that I showed in the last video, and you see it also on the signal coming as the 555 timer turns off. You can also see the little signal there too. Okay, and as I turn the duty cycle of the control of the timer, you can see that let's see, we should be actually triggering on trace 2. As I change the duty cycle of the timer and get into that region where the scope loses trigger on that, there are your characteristic bands of lost trigger. And of course, if I magnify the volts per division, it looks just like what Aaron was showing. Okay, now that was the 555 timer trace. There's the MOSFET trace there. Okay, now what I'm going to do is unplug the lead connecting the 555 timer to the rest of the circuit. Okay, so the MOSFET will die, and now all you see is, I'm going to just go ahead and turn that trace off. Now all you see is the timer trace, and I guess you can see that parasitic oscillation riding on it right there. Okay, and what I'm going to do now is magnify that. Can you see that? See all that nice regular oscillation there where the MOSFET is not switching cleanly? That's coming, or rather the 555 timer is not switching cleanly. All of that is coming from the 555 timer, and that's what's inducing those oscillations in the MOSFET. The timer is not even connected to the Ainslie circuit right now, except through its ground lead, which is irrelevant, except for grounding the scope, of course. And so what you're seeing right there is just the output of the 555 timer. It's a very dirty signal. I'm going to vary the duty cycle now, and you can see how that gets shorter and shorter and shorter to the actual cutoff edge of the pulse, and then finally the scope loses its trigger and it goes away. Now the MOSFET is doing its best to amplify what you're telling it. Okay, so if you're feeding it a dirty signal from a 555 timer, that's what the MOSFET's amplifying. I'll plug the pin 3 lead back in. There we go. And I'll turn the trace back on and turn the time base back down, and there you can see the top trace again is that trace there, which is the 555 timer. You can see its oscillations, and then this trace here is the MOSFET. It is doing just what you tell it to do. And if I trigger on that and change the duty cycle, get it in just the right place, and there you go. 555 timer sending a bad signal to the MOSFET, and the scope losing trigger on that bad amplification. Thanks again.